Welcome back to Mastering Solidity. This is the video series where I'm giving you a crash course in blockchain development. This is video number 5 in the series where we're going to build a complete smart contract together that's going to demonstrate a lot of essential concepts that you need to understand if you want to become a blockchain developer. All right. So before we get into that, if you're new around here, hey, I'm Gregory from Dapp University, and on this channel, I teach you how to become a blockchain master. So if that's something that you're interested in, then click the like button down below and click subscribe. And if you want to learn how to master blockchain step by step from start to finish, I can show you how to do exactly that. All right. Just head on over to dappuniversity.com right now to get started. All right, so what we're going to do in this lesson is build a smart contract that demonstrates several different concepts, okay? So up until this point, we've kind of covered topics individually, like arrays, for example, variables, and we've kind of just created, a single contract called my contract that demonstrates these principles in kind of an abstract way, okay? And I think that can be a helpful approach sometimes. But what we're going to do in this video is actually build a smart contract that has a specific purpose that's going to illustrate several different concepts or introduce you to several different concepts that we haven't quite seen at this point in the tutorial series, okay? So what we're going to do is create a smart contract for a hotel room. And what's going to happen is basically the user is going to be able to pay this smart contract to book the hotel room, and it will automatically open the room for them and allow them to occupy it. So let's go ahead and get started. And when we build out this use case, you're going to see several different things in this lesson. Let's see here, like how to work with Ether, pay smart contracts. Let's see here, how to do modifiers. Let's see, visibility. And also events and enums. All right. So don't worry if this looks like an overwhelming list. It'll all make sense as we build out this entire project. And it won't even take very long. But once you finish, you'll understand all these things and how to create a hotel room smart contract. All right, so the first thing that I want to do is create a way to actually book the hotel room. All right, so we'll start off with a function. Let's see your function called book. All right, and what we'll do is, write the logic inside of here to book it. All right, and what we're going to do is basically allow the user to pay this smart contract with this function, and it will transfer the payment to the person who deployed the smart contract. In this case, we'll just call it the owner. Okay. So let's go ahead and model the owner. So I'll say address, payable, public, owner. This will be a state variable. And remember, this state variable gets written to the blockchain. All right. So the blockchain will know who the owner of this smart contract is all the time. And this is who we'll send the payment to whenever this hotel room gets booked. Okay. So let's store the owner. We could assign it here and hard code the address. But what we want to do is dynamically assign it to the person who deploys this smart contract. They'll essentially be the creator, okay? So we'll say constructor. This will be the function that gets run whenever the smart contract is created, right? Say public. And owner equals msg.sender. All right, so let's recap this here. Don't forget msg.sender is or message sender is the user who the user who calls this function in Solidity, right? So anytime you reference msg.sender or message sender, this is an Ethereum address of the user who's calling this function, all right? And this constructor function is the function that gets called whenever this smart contract is created. It's once and only once whenever the smart contract is deployed to the blockchain. All right. And we're saying the person who deployed this, the person who called this function, they are the owner of this smart contract. Okay. And we store that ownership here in a state variable. This is actually written to the blockchain. All right. We say it's an Ethereum address type. All right. Address. And then payable, we must use this whenever we create the variable so that this owner can actually receive Ethereum or Ether for the payment. And then public so that we can determine who this person is later. Okay. All right. So inside of the book function, what we want to do is pay the owner to book the hotel room. Okay. So we do that like this. We say owner transfer, and then we want to actually send the Ethereum that comes in with the transaction whenever this function is called. So just like we have msg.sender or message sender, we also have message value here, msg.value. All right. So whenever we call the book function, we can send in a payment. We can send in Ethereum, Ether, and we can determine how much that is right here with message value. All right. So in order to do that, we must call this function payable. All right. And then now whenever we call this function, we'll be able to just transfer the ownership. Sorry, not transfer the ownership. Transfer the Ethereum payment to the owner. All right. Okay, so that's step one. Just pay the owner to book the hotel room. Now, the next thing that we want to do is we want to make sure that we can actually book the hotel room, all right? So if it's already been booked once, we don't want it to book again, okay? So we can keep track of the hotel room status, all right? We can basically say, is the hotel room vacant? Or is the hotel room occupied? All right. And then what we can do is inside this function, we can check to see whether the hotel room is vacant or occupied before we book it. All right. So we can keep track of this status like this. We can use an enum. All right. We'll use an enum. All right. So the enum will look like this. Let's say enum. Statuses, okay, and then we'll say vacant or occupied. All right. So what this enum does is it keeps track of a collection of options basically that will never change, and we can reference this collection of options, in this case statuses. And we can change it. We can kind of see what the current status is. So we can track it like this. We can say statuses, current status. All right. And basically we can set the current status like this. We'll do it in the constructor. Basically, we'll set a default status whenever the smart contract is deployed, right? Just like we set the owner, we can also set the default status. Say current status equals statuses that vacant. All right. So do equals here. All right. So basically, whenever we deploy the smart contract, this will be created whenever the hotel room is not booked yet. So we'll say the status is vacant. All right. And that changes it, or that keeps it. That basically is tracked here. Okay. So now what we want to do is whenever we book the hotel room, we also want to change the status to occupied. All right. So we can do that like this. We say current status equals statuses dot occupied. All right, and that will actually change it. Okay. All right, so the next thing that we want to do, now that we've tracked the status, we have a way to track it right here. All right, we update the status whenever we book it to show that the room is occupied. And whenever we deploy the smart contract for the first time, we set the default status. All right, the default status is vacant because by default, no one will actually be in the hotel room. All right. So now we have this book function, okay? And this book function will update the current status to occupied, all right? And then it will transfer the ownership of the ether, or it will send the ether to the owner, all right? I keep saying transfer ownership. My apologies. That's a different concept when you're talking about an ownable smart contract. So anyways, I know this book function, by the way, is not properly named. Like when you book a hotel room, you don't automatically occupy it. Don't worry about that. This is going to change in a minute. But I just wanted to make note of that really quickly. All right. So the next thing that we want to do is add some constraints to this. Okay. So basically we have a function that will, update the status and transfer the ownership. But we have a problem, right? Like you could book this twice, right? The same hotel room, and it doesn't check to see if it's currently occupied, right? And it doesn't check to see if you paid the right amount, right? So we need to add these things to the smart contract in order for it to even make sense, okay? So Solidity has these things called requirements, so require. All right, and basically what we can do is ensure that some conditions are met inside this smart contract before this code gets executed. So for example, we can check the price and we can check status. And basically we can say, if you didn't pay the correct amount, then don't do this. And if you didn't, if it's booked already, if the status is wrong, then also don't do this, right? So it's two conditions that we want to implement in order for, a successful booking to take place. So we can require that the status is correct like this. We can basically say current status equals statuses vacant. All right. And so we can also give it a error message, currently occupied. All right. So let me show you. Basically what's going to happen here is if they try to call book twice, or, while it's currently occupied, and this condition will basically say, if the current status is occupied, then this will fail. So let me explain why. Basically, what require does is it checks to see if this is true, okay? And if it's true, it will just resume execution. Like this line will just basically skip, and these lines will be called, right? But if this expression evaluates to false, then it will halt, all right? It won't satisfy the requirement. And basically these lines won't execute, and any like Ethereum sent in the transaction will get reverted and sent back to the user, okay? Or at least any unused ether at that point, all right? So also we can specify an error message here, which is really nice in the transaction. So if this fails and it doesn't meet this condition, we can say that it's currently occupied, okay? All right, so the next thing will be, we want to check the price, right? We want to require that the user actually sent in enough. We checked the status, now we want to check the price. So we'll do that like this. We say require current, let's see here. How do we want to do this? We'll say, we'll check message value, okay? MSG, or message value. And we want to require that it's greater than or equal to an amount. So we'll specify the amount here. We'll say it's greater than or equal to 2 ether. Okay. And if it fails, we can give a message. We can say not enough ether provided. Okay. So here's our 2 checks. All right. So basically, what's really cool about Solidity is we can abstract these requirements into something called modifiers. And that's the thing I want to show you next. All right. So here's the requirements. Now I'm going to talk about modifiers. So basically what modifiers are is they allow you to take these lines out of your function and put them into modifiers that will go on the function like this, right? And they'll run before the function gets executed. So let me show you an example. So we can create a modifier like this, a modifier that says only while vacant. And inside of here, basically we can just move this like this. And this will run the requirement. And then after this line, we need to do an underscore and followed by a semicolon. And this will basically execute the function body. All right. So now we can just say only while vacant here, and that will do the exact same thing. All right. So we've just moved that requirement statement out of the function and here. So where this really is helpful is if you have a lot of functions, you can basically say only while vacant and, add this to a bunch of other functions. That's where you get the most benefit out of this. All right. So, you do get a benefit by cleaning up your code like this, but sometimes it can be a little hard to understand if you're having to look in multiple places. But if you have a lot of different functions that require this, this is how you reduce the duplication, which is nice. All right, so we can do this with the price check as well, and we can have a modifier that says costs. So we'll do it like this. Basically, we'll say modifier, and we'll say costs. And what we can do is also pass in an argument here. You say uint amount, and inside this function, we can basically move this inside of here. And let's see here. Say require message value. All right, it's greater than 2 ether. What we want to do is actually pass it in here. So uint amount require message values greater than or equal to 2 ether. We want to say amount here. All right. So let's see here. We want to move this here. Costs, and then pass in 2 ether. Yeah. All right. So now both of these checks will run before we execute this code. And we've moved the require statements out of this. Okay. All right. So the next thing that we want to do is, let's see here, talk about events. So events are pretty cool inside of Solidity. Basically, they allow external consumers to subscribe to them, all right, and find out that something happened in a smart contract. So basically, if you want to create a smart lock or something like that that actually unlocks a hotel room and listens to events on the blockchain or something like that, this is a good way to do it. So it could subscribe to an event inside this smart contract, and it will do things whenever this event is emitted. All right. So you can just create a new event like this. We'll say event occupy. All right. We'll say address occupant. This will be the person who opened it, occupant. And then we'll say the amount they paid, uint value. All right. So we'll say we can emit the event just like this. Say emit, occupy. Say msg.sender, msg.value. All right. So it's pretty simple. You just define the event like this, and then whenever the function's called, it will emit the occupy event. And you could subscribe to this, like I said, in a smart lock or something like that to actually open the hotel room. And let the person, or maybe dispense them a key or something like that, all right? So now there's one last thing I want to do before we test this out. We want to basically make this shorthand. So instead of having a named function called book, we want to create a special function in Solidity called receive, all right? And basically what this will do is create a function that will get triggered whenever you just pay this smart contract. So if you just simply, send Ethereum to this address, this is the function that will get called. So like if you open an Ethereum wallet like MetaMask, for example, I don't have MetaMask pulled up right now, but basically if you pay it, you just send Ethereum straight to this smart contract, then it will do this. Okay. So we'll say receive external. All right. You must call it external so that it can be called outside the smart contract. It's payable only while vacant and costs 2 ether. All right. So there you go. All right. So let's go ahead and compile this, test it out. Click compile. All right. So we got a problem here. Let's see here. Modifier. Let's just update this. Let's get a problem with the enum here. All right. Let's just try this. Let's try it again. All right, so we've got another problem here. Let's just check the modifier. I've got the code for this down in the description below, so if you want to actually check it with what I have on screen, you can just look at the GitHub gist. So let's fix the costs. I think I just have a small syntax error here. Sorry, everybody. Yeah, there you go. Okay, perfect. So like I said, I've got the correct code down in the description below if you want to make sure that yours is right before you do this step. Let's click compile. Next, let's deploy it. All right, so just click deploy. Let's go to the first address here. All right. So now we can check the owner like this. There we go. There's the owner. That's us. So now let's go to a different address and actually try to book the smart contract. I'll go to this one that has 100 Ether. And let's try to pay it. Basically, let's do this. Let's say value equals 1. Let's try to send it not enough Ether first. Basically, what you can do is do this low-level interaction. This will send Ethereum to the smart contract. So, we don't see a function name here called receive, right? That's because this is a special function in Solidity. This is how you interact with it. You send a transaction to the smart contract directly. All right, so click transact. Make sure you put in 1 Ether here, all right, to the value. Click transact. And boom, there you go. We got an error. That's what we expect. So we can expand this and see the error down here. Not enough Ether provided. Okay. Perfect. So now what we can do is, let's see here. We could do enough Ether. Click 2. And then transact. And there we go. It worked. It's green. Perfect. So let's try it again. Now that it's already booked, click transact again, and we should see an error. Yep, we do. Perfect. All right. This error is currently occupied. Perfect. All right. So that's our hotel room smart contract. We've demonstrated lots of concepts in this video. The status, the enums, the modifiers only while vacant, the costs, everything. There's so many concepts in this video. All right. So again, you can see the completed code down below. So I hope you like this video. Again, subscribe to the channel if you haven't already, and click the like button down below. That really helps these videos get found so that more people can become blockchain developers. And if you like this video and you want to take that next step, you actually want to master blockchain step by step, I can show you how to do just that. All right. So head on over to dappuniversity.com/bootcamp. All right. Until next time, thanks for watching Dapp University.